Professor Arends, you're the spokesperson of the Transnational Access Programme here at MAMI in Mainz. Could you explain a little to us about the scientific programme here?
Well, the most challenging task of physics now is to study and understand the structure of matter. And matter is composed of atoms, which are consisting of atomic nuclei and electron clouds. And the nuclei themselves are made out of protons and neutrons, which themselves are not elementary particles, but they are consisting of quarks, which are bound together by gluons. Now, the quarks we cannot study in isolation because they always combine into 2 or 3 quark systems, which we call hadrons. Protons and neutrons are the most well-known partners of these hadrons. And so the hadrons are the most basic observable elements that we have in nature, and therefore it's very important for us to study them. And an elegant way to do this is to scatter photons or electrons from them, and then to observe what happens in sophisticated detector systems. And that is exactly what we do here at MAMI. MAMI is a unique accelerator for electrons, which accelerates the electrons to energies of up to 1.6 GeV, which is ideal for doing these scattering experiments. And MAMI is well known for outstanding beam quality and reliability, and it is I think one of the largest accelerators which is operated by a university.
So you describe what we do. The question is, who are we? Who participates in this program?
Yeah, our research program is organized in large international collaborations where we have, of course, our local scientists and the operational crews for the accelerator, and they work all together with scientists from basically all over the world. So we have at present scientists from more than 30 countries, from basically all European countries, and then from United States, Canada, Russia, and so on.
So what do you want to achieve with this international activity?
Well, with the Transnational Access Program from the EU, we have the possibility to attract more scientists from the European countries and associated countries to work together with us on these challenging experiments here at MAMI. And I think it is important to bring in new ideas and new experience to work with us together on these experiments.
So how do the results of this Transnational Access Programme benefit society?
Well, fundamental research of today usually is the technology of tomorrow, and we have numerous examples for this. For example, nuclear physics applications you find in various fields like medicine, biology, material science, archaeology, and for example, we are using here the nuclear magnetic resonance process, the NMR process, to measure the polarization of our target nuclei, and this of course is a well-known process which is used in medicine for medical imaging, for example. But there are of course other benefits for the society which come more from the interaction of people working together and exchanging ideas. So I think this will help and will benefit the society already now.
So Professor Arends, why should a young person choose to study science, and why should they do so in Europe?
Well, I could try to answer this question, but I could also give it back to you, because you for once were a very young scientist from Glasgow coming to Mainz by Transnational Access Program. So I can give back the question to you.
It gave me great opportunity. The Transnational Access Program supports the travel of young researchers who maybe don't have so much money of their own in order to come here. And in the course of my PhD in MAMI, I built a detector, I ran an experiment with the detector, I simulated the experiment, and I analysed the data. And it's really an all-round programme, and when you look, as a student, you notice these things. When you look at the leadership of many of the international labs, it comes from the programme here at MAMI simply because it allows you to see so much of the experiment, and the Transnational Access Programme enabled me to participate more fully in this rich programme of science. So here we are with some of the young researchers from the A2 collaboration at MAMI, and I wanted to ask them, why should young people study science, and why in Europe?
So the physics is very exciting science, I think. It's very interesting to study. It is very important for our economy development. It's very important for our culture development, and it's just fun.
Why Europe?
Yeah, I think Europe is a good place to do physics because we have many scientists here in Europe, so everything is quite small compared to other continents. So we have a huge density of universities and scientists, and yeah, you can really do science at the end of college. Yeah.
And with so much of Europe to choose from, why did you choose to do physics at MAMI?
So you can do really frontier science in MAMI. MAMI is a very good opportunity to do experiments. It has very good quality of beam. It has very good intensity for do such to produce such real physical events as we do, and it is really a unique accelerator in whole world.
Yeah, and so to say, there's a good size, I think, overall. So you can really look into the different parts. So you can visit MAMI and look how the beam is produced, but you can look to the detectors, you can maybe understand some things. Yeah, I think it has a good size.